Right, welcome to today's live stream. We've got some questions on circles, and without further ado, we'll get started on the first question. So here is question 8 from the sheet. I'm going to give you 5 minutes to have a go at this one. Right, here we go. So we've got a circle, center C, radius r, and it has this equation. So what we do is we try and complete the square for this bit of the circle. So we're going to get x, we've got minus 8x, so we're going to get minus 4. From completing the square, we get x minus 4 all squared. And then we're going to have added to that y, and we've got plus 2 when you halve that value squared. Now I need to take away from this 16 because we're going to get minus 4 squared. I need to take away from this 4 because we're going to get 2 squared coming out of this. And then we've got the minus 12 up there, and that gives us 0. So we get x minus 4 squared plus y plus 2 squared. And then that's all going to equal 32. And what we can see is we've got the coordinates of the center of the circle. So C will have the coordinates of 4 minus 2. So that's our answer to A. And our exact value of R is going to be the square root of 32. So R will equal the square root of 32. That's our answer to B. So for part C, find the coordinates of A and B where the circle cuts the y-axis. So it's going to cut the y-axis. Let's do part C up here. It's going to cut y when x equals 0. So therefore y squared, to make this x equals 0, we're going to get, and it's easier to put it into this, x equals 0, we're going to get y squared minus 0 plus 4y minus 12 equals 0. And then we can factorize that to get y plus 6 and y minus 2. And therefore y will equal minus 6 or 2. So the coordinates, notice it says coordinates, are going to be 0 or 0, 2. So next question we've got coming up is this one. Okay. Question 9. Sorry, it's a little bit small. I'll read it through to you just in case you're struggling to read that back at home. The point A is 1, 4. The point B is 7, 8. And these lie on C1. Two distinct circles, C2 and C3, each have center 0, 0. Given each of these circles touch C1, find the equation of the circle C2 and the equation of circle C3. Again, going to give you another 5 minutes to have a go at that one. Right, here we go. So let's have a look at this. We've got points A, 1, 4 and B, 7, 8 lie on C1. And given AB's diameter of the circle C1, find the coordinates of the center. So if this is the diameter, so if we've got, I know, A could be over here, for example, and, well, that's actually 1, 4 and 7, 8. So 1, 4, 7, 8. So let's just say they're more like this, aren't they? So A could be over here and B could be over here. Therefore, the center of the circle must be halfway between these 2 points. So we can find the center is going to be equal to 1 plus 7 over 2. And then we've got 8 plus 4 over 2. And that will give us 4, 6 for the center of our circle. And we can find the radius by finding the distance between these two, between the center and one of these two, or we could find the distance between these two and divide it by 2. But we'll do the center and one of these two. So we'll have from A to the center, so the radius will equal the square root of the difference between 4 and 1, which is 3 squared, plus the difference between 6 and 4, which is 2 squared. So that is going to give me the square root of 13. And we want the exact value, so therefore that's our answer. Now, we've got 2 distinct circles which have a center at 0, 0 here. And given each of these touch circles C1, find the equations of circle C2 and equation of circle C3. So what must happen is that, okay, for these circles to just touch at this point, they must actually be like in this position here. So they must go along this diameter here. So we need to first of all find this point here, and then we can find this point here. Now we can find the distance OC is going to be root 13. So therefore, we know that we know that the distance from O to this point here, okay, we can find that distance by finding this distance and then taking away this radius. And we know this one's center is going to be at 0, 0. So what we're going to do is we're going to find this distance, then take away root 13 from it, and that gives us the radius of this one. And then obviously, once we've got this distance, we add root 13 to get the radius of the big circle. So let's go for C, and we're going to do part C2. So if we do OC, let's put C there, and we're going to put D there. So let's find OC, and that's actually, let's go find O and the center. Sorry, I meant C to be the center. Apologies, a little bit confusing. OC is going to be that distance there. Okay, we know the center of this circle, so it's going to be 4 squared plus 6 squared. So it's going to be 16 plus 36 rooted, which is going to be equal to root 52, which equals 2 root 13. So the radius of C1 is going to be equal to root 13 as well, because if we take root 13 away from 2 root 13, we get just the square root of 13. So therefore C2 is going to be x squared plus y squared equals 13. Now, we now know that the distance to D is going to be 3 root 13, because we're going to add the root 13 onto the 2 root. We've got this 2 root 13. We know that's root 13, so it's going to be 3 root 13. So therefore, for C3, we're going to have x squared plus y squared is equal to 3 root 13 all squared. Just move down slightly to get some more space in. Put a final answer in. So we get x squared plus y squared. Well, that's going to be 9 times 13, which gives me 117 for that. Why have I just gone for x squared plus y squared? Because the center is 0, 0. So I don't need to take anything away from the x and y values to get my center of my circle from that equation. Okay, so that's how we go about doing that question. Right, next question. Let's give you another 5 minutes to have a go at that one. 5 minutes, off you go. Right, so here we go. We're going to find the coordinates of C for this, which is pretty much the same as the first question we did. So we get x minus 3 all squared when we complete the square of the x's. And then we're going to complete the square for just the y bits as well. So we get y minus 7 all squared. So that's going to mean I need to take away 3 squared, which is 9. I'm going to take away 7 squared, which is another minus 49. And I've got this plus k here equals 0. So I can find the coordinates of the centre of C. I'm just going to get everything on the other side just for completeness, ready to do the next part of the question, because I'm going to need to do that anyway. So I'll get everything onto the other side. So I'm going to get 58 minus k on the other side. So the centre, so part A, the centre is going to be at the point 3, 7. And we want to find the radius when k is minus 32. So r will equal the square root of 58 minus 32. Remember, whatever on this side is the square of the radius. So therefore, r will equal the square root of 90, which is equal to 3 root 10 when you simplify that down. Now, find the range of values for k for which C lies completely in the first quadrant. So if we can draw ourselves, right, get myself some axes. And it's not going to let me do that, so I'm just going to draw it freehand. Here we go. So if we've got our point at, it's going to lie completely in the first quadrant. We know the centre of our circle is going to be at 3, 7. So we know that this distance has got to be less than 3, and we know that this distance has got to be less than 7. So the radius is going to have to be between 0 and 3, because it's got to be bigger than 0 for there to be a circle. So we know that the radius has got to be greater than 0, and we know that it's got to be less than 3 to satisfy that inequality there. So therefore we've got 0 is less than 58 minus k is less than 3. Take away 58 from each side on this inequality, you get that, and we're left with minus k, and we take it away from the 3, and we get minus 49. All right, I've made a mistake here. I made a mistake. Oh yes, r is between 0 and 3. 58 minus k is going to be between 0 and 9. Okay, because 58 minus k is r squared. So 58 minus k is between 0 and 9. So when we take 58 away from 9, we get minus 49 here. Now, we've got minus k. If we change the sign of that, what this means is we change the sign of this, and we'll change the sign of this. And then this has to flip around, and this gives us our values for k. So k must be between 58 and 49. All right, next question. I'm giving you 5 minutes to do the next question. Sorry, I didn't page down. Do the next question. There we go. Next question for you. Give you 5, actually probably won't be 5 minutes. It's only a 5-mark question. Let's just change that to a 3-minute question. Right, so on this question, we want to write down equation C in terms of A. So what we've got here is we have a circle, which the center of it is going to be A0. So we're going to have x minus A all squared, because the x coordinate of the center is A, minus y squared, because the y value is 0, equals, now the radius must therefore be A, so it's going to equal A squared. So that's our answer to part A. Part B, given that point 4 minus 3 lies in C, find the value of A. This really should have been quite a straightforward question. To put the 4 in, put the minus 3 in, and let's see what we get. So we're going to get 4 minus A squared, so we're going to get A squared minus 8A plus 16 minus, a bit of a mistake here, plus y squared there. So plus y squared there. So we're going to get a plus 9 here equals A squared. So the A squareds cancel. So we're left with 8A will equal 25. So therefore A equals 25 over 8 is our final answer to this question. So there you go. That's all we're going to do on circles. By the time you get into the second year, it should be quite straightforward, these questions. So I hope you have a happy new year and see you in the new year with the last few in this series next week.